The domain of a function is the set of x values that can be plugged into an equation and yield y values that are real. So let's say we had an xy coordinate plane and we had a line going through it. The x values, or the values along the x-axis for this function, represent the domain. So for what x values does this function exist, essentially? The vertical line test is a method of finding the x values of a curve with no corresponding y values. So let's take this line, for example. We can use a vertical line to try and find any breaks in this line, and there are none. So the domain is the smallest value is negative infinity, because this line continues indefinitely, which means all of these negative real values for x apply. So it will continue to negative infinity in this direction. And then as we proceed in the positive direction of the x-axis, same thing. This function will continue for every value for x in the positive direction. So the domain is negative infinity to positive infinity, and parentheses are always on the side of infinity since it is not an actual number. But let's say we had this function instead. Now when we use a vertical line, we see that once we get to where x is equal to -2, there is no y value. And we continue and we see where x is equal to +4, there is no y value. So now our domain is a bit different. The first interval of our domain is from -infinity to -2, and that represents all the ordered pairs not shown, all the way up to the portion of the line we see, up to where we get to the gap in the line, this empty circle. So this interval of our function is represented by this right here. And we'll dive deeper into the details of this notation in a minute. You're going to place a u between the intervals. And now this second interval is from -2 to +4. And notice we have parentheses since -2 is not included, since the circle is empty. But this second interval is from -2 to 4, represented here. Another u between the intervals. And then the third interval is from +4 to +infinity. And we have parentheses on both sides since 4 is not included, since it is empty. And infinity is not real. It's just indicating this will continue indefinitely. So that is how you would use the vertical line test to find the x values that do not have corresponding y values. And then this will help you write your domain. So let's briefly discuss the range of a function. The range of a function is a set of y values that are possible results of the function. So you will need to pay attention to the y values where there may be a gap in the function. The horizontal line test is a method of finding the y values of a curve with no corresponding x values. So like our original line, for example, if we use a horizontal line, we see that there are no gaps. So the range would be from -infinity to +infinity, since this would continue indefinitely, heading all the way down towards -infinity on the y-axis. And as we continue up, we see that it is going to continue to have y values as we head towards +infinity. But let's say this were our function. Now when we use the horizontal line, we see there is no x value when y is equal to 1. And as we continue, we see there is no x value when y is equal to 4. So the range would be from -infinity to +1 for the first interval. And we have a parenthesis on the right side of number 1, since 1 is not included, since this is empty. You place a u between the intervals, and now the second interval is from where y is equal to 1 to where y is equal to 4. So we have 1, 4 in the middle. Another u between the intervals, and now the third interval is from y is 4 to +infinity. So that would be this section here. And it would continue. So let's discuss interval notation a bit further. The set of values from an inequality can be represented by a form known as interval notation. So we have a is less than or equal to x is less than b. And in interval notation form, we would have a bracket, the letter a comma between the entries, and then b would be the second entry here, so there is no x in the interval notation. The smallest value and the largest value of the set are enclosed by either a bracket, if the value is included. So we have less than or equal to. So x can equal a, so we use brackets. So that is why we have a bracket here beside a. Or a parenthesis if the value is not included. So that would be this portion here. We have x is less than b. But since x is not equal to b, we're going to use parentheses in those cases. So that is why here we have b, the larger entry, has a parenthesis to the right of it. Sometimes, as we saw in a previous example, you'll have more than one number that is not included in the domain or function. Two or more intervals may be joined together by a u between each interval. So let's say we had the number line and the domain were all the real numbers except -2 and +2. So this first interval would be from -infinity up to -2. So that's here. We place a u between the intervals. And now the second interval is this middle section here from -2 to +2. They're both empty. So we have parentheses instead of a bracket or brackets. A u between the intervals. And now this third interval here is from +2 to +infinity. So that would be here, the smaller entry on the left, a comma, the larger entry on the right. So this is the layout you would use if you had two numbers missing. It would wind up being 3 unique intervals or sections. Okay, so keep that in mind. Now let's walk through an example together. Let's say this were a sketch of the function f of x. The first question is, what is the domain of f of x? And the second question would be, what is the range of f of x? So let's have a look. So to find the domain using this graph, step 1, use a vertical line to find each x value with no y value. So we'll start at one end of the function and we'll work our way to the other end using a vertical line. Towards the left end, where x is equal to -5, there is no y value. So we'll need to make a note of that. We use the vertical line along the function, and we see that there are no other gaps. But at x is equal to -3, we have a filled-in circle, which lets you know the function ends here. So the domain would be from -5, parenthesis to the left, since -5 is not included. And it would continue to the largest possible value of 3, which is included since it is filled in. So this would be the domain. And now to find the range, we'll focus on the y values of the function. So we will use a horizontal line to find each y value with no x value. We'll start towards the left and work our way to the right again. So where y is equal to -4, there is no x value. So we'll need to make a note of that. And we use the horizontal line and see that all y values are accounted for up until we reach y is equal to +6. So the range would be from -4 to +6, parenthesis on the left side of -4, since the value is not included, and a bracket to the right of 6, since that is included. So that is how you would go about finding the domain and range using a graph. Let's now have you try a few practice questions. Question number 1. What are the domain and range of this function? Question number 2. What are the domain and range of this function? Pause the video, answer these questions for both questions 1 and 2, and then press play when you are ready to begin. Question 1a, we'll first focus on finding the domain of this function. So step 1, use a vertical line to find each x value with no y value. So we'll start towards the left and make our way to the right. And at the very end of this function, where x is equal to -4, there is no y value. We continue along the curve, and we see all x values are accounted for until we reach x is +4. So the domain would be parenthesis, -4, comma, +4, with a bracket to the right. Now we want to find the range. So step 1, use a horizontal line to find each y value with no x value. So we'll start at the bottom and work our way up. And we see that between y is equal to 1 and y is equal to 10, there is at least one x value for each corresponding y value. So the range would be from 1 to 10 and brackets on both sides. Since 1 we have a value and at 10 we have a value. So those are the answers for question number 1. Let's now have a look at question number 2. So question 2a, we are finding the domain of this graph. So we will start at the left side, and we see where x is equal to -6, there is no y value. We continue with the vertical line, and we see that all y values are accounted for until we reach x is equal to +7. So the domain would be parenthesis -6, that's the smallest x value, up to 7, the largest x value, with parentheses enclosing them, since neither number is included in the function. Now let's take a look at the range. We will use a horizontal line to find each y value with no x value. So we'll start our way at the bottom and work our way up. So the range is from -5, and we see all y values are accounted for, even though -6 has a circle here and 7 has a circle here. We have a value at the origin here. So y values are accounted for between -5 to +3. So we have brackets enclosing -5 and +3.